continuing with rational functions for a little while, we'll look at some more fun ones. Let's take the limit as x goes to 3 of x squared minus 3x divided by 2x squared minus 5x minus 3. And see what happens here. And so my default reaction for something like this, so I'm just gonna plug it in because the limit laws say if the limits exist, then I'm good. Okay. And earlier I was calling that cheating, but now that we have those rules, it's not really cheating anymore. So if I plug in 3 here, I'm gonna get 3 squared minus 3 times 3. Ooh, that's a 0. Down here, let's see, what are we gonna get? We're gonna get 2 times 3 squared minus 5 times 3 minus 3, which is what? 9 times 2, 18 minus 15 minus 3, which is, 0 again. Okay, so this is a problem because there's a 0 on the bottom. Zero in the denominator, and the problem is even more complicated because I have a 0 on the top. If this was like 3 over 0, then I'm kind of done, but not really. We'd have to check both sides to see what's going on there. So when you get 0 over 0, the next thing to say is, okay, we can either look at this numerically, or we could see if we could apply a little algebraic jiggery-pokery to that thing there. So I'm going to attempt a little algebra on that by saying, hey, maybe this factors. So yeah, the numerator factors as x times x minus 3. And the denominator, let's see, that would be 2x times x. And then I think it's going to be a 1 and a 3 and a negative and a positive. Does that work? That gives me 2x squared minus 3, and then it gives me negative 6x plus 1x, which is negative 5x. Okay, so that's the factorization. So here is that, and then we have this common factor, top and bottom, that divides out to be a 1, meaning that as long as x isn't 3, which it isn't because I'm taking the limit, and the limit says approach 3, but don't touch it, this should be equal to the limit as x goes to 3 of x over 2x plus 1. And then I can apply the limit laws and say, okay, this should be the limit of the numerator, which is 3, divided by the limit of the denominator, which is 7. So I think this should go to 3/7. And again, this was one of those complicated ones, so we probably should find a way to double check. Graphical is a good way. Table of values is another good way. Sometimes I do both, depending on how complicated it is. Let's start graphically here. So I think we're done with U at the moment. I'll just leave that there and rewrite this sucker. So we've got, what was that, x squared minus 3x. So 3x squared, that 2, and then down here we have 2x squared minus 5x minus 3. Type that correctly, x squared minus 3x, 2x squared minus 5x minus 3. I think that looks correct. And then we want to evaluate it at 3. And this says f of 3 is 5/12. Is that true? Oh, no, it didn't. I had to hit enter to re-evaluate it. And it says, hey, that is undefined. All right, so let's see. 3 is right here, x equals 3. So let's just graph x equals 3 there. And it looks like there should be something, but the calculator said there's a hole there. And my earlier evaluation says, yeah, there's a hole at that point right there. And I could zoom in all day long at that point, and I'm not going to see anything. So let's hide that. There we go. So I could zoom in there. A cool thing about GeoGebra is if you go to the graphics move tool here from the tools menu, then I can grab that axis and stretch it out. And then go over and look. Let's see what I'm looking for. X equals 3 is now way over here, which is kind of fun. And it turns out it doesn't matter how much I zoom in there. I'm not going to see that hole because the computer doesn't know it shouldn't skip over it. So let's turn that off again. But there is a little tiny hole right over there. We think the whole is at the point 3, comma, let's see, what did we find? That was 3/7. Boom, there it is. So that point does seem to sit right on top of where the hole in the original function exists. Cool, checked, done. All right, another bit of fun. Come on, new page, please, there we go. Let's try the limit. Should we always factor? The answer is you should do some kind of algebra. So colas, should we always factor, even if it works with the original? No, so if you evaluate a rational function and you got a number, cool, done, no need to factor. It just resolved. If it doesn't resolve, so 0/0 is again what we call an indeterminate form. Indeterminate means I didn't resolve this problem, then I have to do something else. And in this case, algebra worked. Will algebra always work? The answer is no, it won't. Sometimes we have to resort to some other tricks, which could be a table of values like we've been doing so far. Good question. All right, so let's not write it red here. So limit as x goes to -1 of the square root of x plus 2 minus 1 divided by x plus 1. And if you look at this, you should see right away a warning like, oh, if I plug -1 into the denominator, I'm going to get a 0. That's trouble. Now, if the numerator is something other than 0, I'm okay. I just have a little bit more work to do either way. But if we try to plug into the numerator 2, then we're going to get what? -1 plus 2 is 1, square root of 1 is 1, 1 minus 1 is 0. So this resolves to 0/0. So I have to throw some other trick at it. And it could be we just jump to a graph right away and see, hey, let's see what it looks like at -1 before we apply a little algebra, and that's all right. I'm going to reset, get back to the origin. And call this f of x again for the heck of it. And it is a fraction with the square roots of x plus 2 in the numerator, then -1, and then x plus 1 in the denominator. Oh, and look at it, showed the hole this time, huh? GeoGebra's getting smarter. It didn't do that last time, but it did this time. So the closed circle means, hey, that exists. The open circle means, oh, something's weird right there. And we know from our work just a minute ago, if we try to plug in -1, we get, huh? Got no answer for you there. So something's going on, but it looks like it might be around a half, okay? So we could zoom in there and look at points in that region. Let's see, GeoGebra has a nice feature where you can just take a point and put it on a function right there. And then if I go back to this window, I can see the value of that point. And then I can take that point and move it toward that place and watch what the y values are doing. Now, if I actually get to that place, I should get no answer. And this skipped right over it when it was trying to get over there. But it looks like, oh, I did hit it. Oh, undefined right there. Okay, it looks like it's around a half. Okay, I'm a little below a half there, I'm a little above a half there. Is it a half? I don't know yet. The computer system can't tell me unless I make a careful list of values like I did in the spreadsheet the other day. All right, back here. So algebra for something like this, when you have roots involved with a sum or a difference, is to use a conjugate of the root. So conjugate of the root, which in this case would be the square root of x plus 2 plus 1. So we just change that difference to a sum or sum to a difference outside of the root. We're going to multiply top and bottom by that. So we've got the square root of x plus 2 minus 1 over x plus 1, and we're going to multiply that by the fraction that has the square root of x plus 2 plus 1 in the top and the square root of x plus 2 plus 1 in the bottom. So this green fraction is equal to 1, so I'm multiplying by 1, which really doesn't hurt this function, it keeps it equivalent. So we've got a little distribution to do here. So parentheses involved, start multiplying. So I'm gonna let you get this started and then I'll catch up to you in a second. So hopefully you were writing this down. If not, write it down and start distributing. Okay, I think I've got the first round there, distributing the x in the bottom, and then distributing the 1. In the top, we have the difference of two squares. The square root times itself is x plus 2. Negative 1 times positive 1 is negative 1. So my numerator is now x plus 1. Correct. Yep. And my denominator, does that clean up at all? Not really. No, I don't see anything that cleans up. You guys? All right, so we rewrote it, and the hope is that after multiplying by that conjugate right there, something interesting should happen. So now we go back to our limits. And so usually I just do my algebra, not writing the limit each time, and then come back in with the limit once I think I have it simplified as much as I can. Oh, yes, I see. This does simplify. If I look back at my denominator right there, I'm going to leave that denominator in factored form because then we get things to cancel. So x plus 1 in the top, in the bottom, that is also written as x plus 1 times the square root of x plus 2 plus 1. And in this case, x plus 1 divided by x plus 1 is 1. And so now I have the limit as x goes to negative 1 of 1 over square root of x plus 2 plus 1. And the limit laws say as long as the limit exists, well, the limit of the numerator is 1. If we plug in, the limit of the denominator is 2. And so, yep, we do get a 1/2 there. So we're able to use a little algebra to get rid of the 0 over 0 problem. In this case, it was multiplying by a conjugate. So the thing is, when you do get a 0 over 0, which is what we call in mathematics an indeterminate form, meaning I don't know what it is yet, but it might be something. In this case, 0 over 0 is a 1/2. And it's different every time. Sometimes it's infinity, sometimes it's 0, sometimes it's pi. It could be lots of things.